Now, our class, this is not truly random. Why is this not a randomly sample? If I were to sample you, it would not be random because you're all college students. You already have proven your intelligence by being accepted to DBU. You excelled in high school, you studied hard, you worked hard, you took the ACT or the SAT, you made it into DBU. So this would not be random, and so this would break down a little bit, but you can see, if I were to go out and just randomly select a person and have them take the SAT, or the ACT, excuse me, there's a 97% chance that they would score less than a 30. And let me get that filled in here. Okay? And the picture is really the key. The picture is the key because it shows everything that we need to see. Now, later today I'm going to introduce a visual exploration on this topic in Excel. So we'll be able to click and we'll be able to watch this develop in Excel. So for those of you who are visual learners, it'll come to life in Excel. But I want to reiterate the fact that this is called a continuous probability distribution. Okay? The normal curve is one continuous probability. We looked also at the uniform curve. Briefly, we looked at the exponential curve. Okay, these are all continuous probability distributions. They all have a probability. But we know that probabilities can go from 0 to 1, from 0% to 100% chance. Okay? So, if I ask you what is the probability, you should come up with no answer other than 0 to 1 or 0 to 100%. There is no other answer available. If you would tell me what's the probability of something happening, you tell me 162, that's wrong. This is wrong. Right away, we know this is wrong. It is not in the bounds of probability. Probability rules we looked at in Chapter 4, they tell us that it has to go from 0 to 1 or from 0 to 100%. So 162, it just doesn't lie in probability. So that's step number 1. So if I ask you, what is the probability that something happens between this and this? You know your answer is going to be bound by 0 to 100%. Okay? So if I drew a random mean, and let's say that would be 10, with a standard deviation of 2. So if I were going to draw this out, and I encourage you to do that with me, 12, 14, 16, 8, 6, 4. What is the probability that that if I were to randomly select an item, it would be between 8 and 12? There are two ways to go at this, but we know that these are one standard deviation apart. We can use the empirical rule that would tell us 68%. Or we convert them to z-scores, and I say 12 minus 10 over 2 is positive 1. 8 minus 10 divided by 2 is negative 1. And I look up positive 1 if I look up positive 1, it's going to give me 84%. Then I look up negative 1. And I encourage you to do that with me. It gives me 0.1587. I'll round it to 0.16. Okay? 0.16, 0.84. And this 0.16 visually represents this part of the curve. Now, visually it represents this part of the curve. So, what can we do if we take 0.84 minus 0.16? I'll give you a second to do that. What do you get? Okay. 68%, or 0.68. Okay? So, we use the normal curve to manipulate, using the Z formula, we manipulate the normal curve to help us with our probabilities. Now, we're going to take this one step further. Looking at chapter 7. Looking at chapter 7 on page 253. We see something called an SRS, or a simple random sample. Okay? A simple random sample. We are now moving past selecting just one observation and looking at the way they fit with the curve. Now we're going to sample more than one person. We're going to sample 10, 20, 30, 100, 1,000, 10,000. Okay? And we're going to look at our sample. We're going to take our data. We're going to make decisions about our data that our sample gives us, or our statistics that our sample gives us. We're going to make inferences about the population parameter, okay? And that will take you back to lecture 1 in our box. We have a sample. We get a statistic. Oh, excuse me. Let me remember. We have a population from which we draw a sample. Okay, so this could be 1 million. Big group. This could be 100. From this we get a statistic. From that statistic we guess the parameter to make inferences about the population. Okay? So, we're getting our sample now in chapter 7, and we're going to begin to make statistics from our sample. But first we have to have good sampling techniques. So, a simple random sample. Simple random sample is primary and fundamental in statistics, to be able to identify something as truly random. In reality, nothing is truly random. Okay, in the Christian worldview, we believe that everything is ordained and has a reason and a purpose given by God, and so there is no true randomness in the universe. But if there could be a randomness, or there existed a randomness in some theoretical principle, then we would draw randomly with that information. But the problem is it's very, very hard. It's very, very difficult. What am I talking about? Well, how if you were going to design a survey to poll the American public to see what they think about Obama? Well, how do you go about starting? You have to first identify your population. Your population would be all voting Americans, I assume. And then a way to get at them, a sample frame. How to put all Americans into a box first to be able to draw them. So that's difficult. How would we do that? Probably phone numbers from the phone book, but that doesn't include homeless people. It doesn't include people with only a cell phone, so that's not a good idea. Maybe you would try census data, but again, census data is old and hard to get at. So how do you really find everybody? Well, it's impossible to find everybody. So what do people normally do? They just use the phone book. And then you assign everybody a number. They have a unique number, their telephone number. So each number then, put them in order from least to greatest. So the individual who has a telephone number 001, 0001, or whatever, he would be first, and so on and so forth, on down the line. Then we've put our sampling frame together.